Very good morning. Hope you had a good start of a week. This is Edith Gutmann speaking, part of the training EMEA team. And I would like to welcome you to today's webinar with our presenter Michael Anton about the topic Advanced Materials for F370. Before I hand over to Michael, just wanted to let you know, as usually, if you are here more often, you know my explanation already. You realize that you are muted. Nevertheless, we still very glad about your feedbacks and also hope that you will pass on your questions. We will have after each chapter always a short break where Michael will check whether there are questions. So please feel free to use the question field to type in your questions. We will read them aloud and then Michael can answer them. And we also have at the end of the webinar Q&A session where you could, if you wish, use the raise hand function and we unmute you, then you can discuss directly with Michael. We will record this webinar as usually and we will share it with you on the Stratasys Academy. If you are a customer and don't have an account yet, you can also request an account. Just contact us at the end of the webinar. And otherwise, I just want to wish you an interesting webinar and we'll pass on to our speaker now. Welcome, Michael.
Thank you very much, Edith, and a wonderful good morning. For all the attendees and colleagues and partners and our customers. So we are directly starting with the content of this webinar. We starting with a short recap about the engineers' pains they have today. Then we go over to the F370 and the advanced materials and applications. Then we have some new case studies, and I will make, as Edith said, some short pausing for your questions, and if there are some questions, we answer them directly. And of course, at the end, you have enough time to have your questions. We can discuss, and at any time you can call us later or send us emails to raise your questions and to get an answer as soon as possible. So start with the engineering pains as a short recap, as said. If you are an engineer today and you need some prototypes, you need parts or assemblies, and you need them for functional testing. This is the first one. Yeah, are they accurate enough? Are they tough enough for testing? You have to physically compare prototypes. You want to save time, of course, and you need multiple versions at the same time to put them on the table or to play with them on your assemblies or systems. Another one is there was a way for students to quickly design, fail, and redesign studies. This is also important because you have a first version, then you print it out, and then you see there is some things needed, or I have not enough room for a handle or for something for design for features. Then you want to redesign and try it again, and you want to have it in the best case next day. So you need a quick solution here, and of course. Your previous printer took too much time and is work and could not get the needed support and work with a single material only. So this is all pain points we address or you have to address, and we will show you the solution for. And then we come to the solution we can offer with an F370 because this is a shorter time to market. Yeah, there's an easy customization as responsive, and you have flexible tools. You can do rapid prototyping with complex and finished assemblies very quickly, and you keep your intellectually properties in house, so you don't need to share your design, your ideas with a service bureau. Sorry. Yeah, keep your confidentiality with you, and of course, you can enjoy a wide range of materials and applications by using our Stratasys F370 printer. Yeah, directly come to some use cases in the RP cycle, and you have jigs and fixtures, of course, and the F370 give you the full bandwidth of the possibilities. So you can print parts for concept verification, you can check and validate your designs, you have materials and applications for functional performance, and it becomes more important every day. You can design and print and assemble parts with to jigs and fixtures, um, and this is yeah every day more what we see, and we have the right materials for this application. So let's review some solution details, and yeah, jumping directly into the F370 for engineering applications. Um, this delivers you the most effective prototyping for all levels of users to get high quality parts printed right the first time. So you have no trials cycles, you have no different multiple restarts, you have no job interrupts. This is the idea of the system. Yeah, we with GrabCAD, it's easy to use and very office friendly. You have a good accuracy, details, and repeatability of complex geometries. You have the fast draft mode, the big build envelope, and 2 times the throughput of an older system. And of course, we deliver engineering grade materials and a new cost effective PLA option, and this together with an caustic soda soluble support. The F370, with the highest capability and largest build size, create complex durable parts for prototyping applications as well as for manufacturing jigs, fixtures, and tools. And available materials is ABS, PLA, ASA, DRAN, PCABS, ABS EST7, TPU, and this all together with the quick support release, our support material. It runs under GrabCAD with 4 slice heights, 4 material base, 2 for support, 2 for material, and of course an auto material change over. And this brings us to the smooth workflow. You starting your job with GrabCAD Print. This is yeah also as application on your mobile. You can monitor this job. You have the inside software as an integrated part of this complete package, and the machine themselves gives you an intuitive interface, so it's very easy to start your print and see all needed informations on the screen, yeah, like you see it here on this little picture. The next one shows you the all the materials we deliver in the F series. You see here in the F120, 170, 270, but today we're talking about the F370. We deliver some standard materials, ABS, PLA, ASA, of course, and but in the F370, you have all the standard materials, but more engineered materials, what we don't have on the other systems of the F machines. So we talk about TPU, what's flexible and durable. We talk about the material DRAN 410 MF07 with a high lubricity. We talk about an PCABS, one of the toughest material with a good temperature resistant. We talk about the ABS ESD7, what is a material with static dissipative properties, and all this together with our soluble support solution QSR and SR30. QSR is SR35, and for some materials we have also SR30. So coming to some advanced materials and applications, and going to the RP cycle for concept and design validation, and then for functional prototyping. So we start with the PCABS with the highest impact strength, excellent feature definition, and surface finish. Here you see some highlights of the PCABS. It's a production grade thermoplastic material, and with the most desirable properties of both materials, the superior strength and the heat resistance of PC. So it's a perfect combination of ABS, a copolymer of ABS and polycarbonate. The material is mostly used in the automotive and electronics industry, but of course in the telecommunication industries and many others where you need toughness, strength, and good temperature behavior. So this is available in black and white color on the F370 printer, and the top applications is conceptual modeling, functional prototyping, manufacturing aids and tools, and of course production parts and use parts where you need it. The next one just shows you the PCABS datasheet details, and you can find them on the My Stratasys or on the stratasys.com website. So we don't go to all this one, and we jump directly to the next engineered material. What is the TPU 92A? It's an elastomer material. It's running on the complete Stratasys F123 series. So the TPU is also running on the F170 and the 270. Here we have normally the movie, but we all know this movie, so I jump over this. If you want to see this movie, please send me a mail, or if you need it to distribute it to your customers, please send me a mail and I deliver the movie per mail or per download. It's not an issue. It's more important to see some nice parts. As I said, the TPU 92A, was the short value of 92A, is an FDM elastomer with a high sought after material used in the automotive industry, as well as other industries. This require flexible parts, and this is absolutely useful for prototypes and the design phase. The properties is a shore value of 92A. It's working together with the QSR, what is an SR35 support material. It gives us an elongation up to 500% and the tear strength of 84 kilonewton per meter. What ends up in a really high tear resistance for final parts, for end use parts, and so on. Industries, of course, is the automotive, the industrial production, consumer product, and sporting goods. It's available on the complete F123 series, but not on the F120, of course. Runs together with GrabCAD, of course. And top applications is hoses, tubes, air ducts, console liners, cup holders, seals, gaskets, and grommets. Of course, grips, surface protection covers, bellows, door and window trim and seals, body panels, and for large and complex parts, consistently and reliably built, so you can print a short series of these parts, and every of these parts looks and works the same. What is needed on the F370 to use this TPU material? If you purchase a new F370, so this is the number, the new one, and for existing F370 customers, there is an elastomer extrusion kit for self-installing available. So the new machines, including the elastomer kit, and if you have one of the first F370s come on the market before we introduced the TPU, you can order the extrusion kit for self-installing. What is the content of the kit? Yeah, of course, it's the head. This head is blue, yeah, to make a difference to the gray and the black heads for other materials. It contains one spool of the TPU 92A filament. In black, it's black material. It contains 60 cubic inch. It contains two upper Y block parts, an install brochure, and of course the web address to download some best practices document. And this is, as I told you, the self-installing. It's quite easy and everybody can do it. Coming back to some best practices, what is the purpose of this document? You can download this one for joining and repairing parts, are routine operations for all manufacturing processes. The common application is joining section parts, joining flexible assemblies, repairing parts, and of course if you download this presentation in the PPTX, you have here the link to this brochure to download it. Sealing, how to sealing the FDM TPU. Some here in this is another brochure. It describes an effective way to expand the number of applications by sealing the parts. The sealing process infuses a sealant into these parts. It makes it more dense against pressure of air and water and other liquids, so gas, for instance, or whatever liquids, and it keeping liquids from leaking through the parts. This is can widen your applications to a complete different field. If you have a problem that you have a thin wall part and you need it completely leaking free, for if you want to with some water or some other liquids, then please use this sealant, what is described here in this brochure, as well as here the link to download. I hope the most of you are already knowing this page, what shows the absolute most used applications in the automotive world for interior and exterior parts and for under the hood applications. You see here the hood seal, and so on, door seals, glass running seals, and capsule lamp seals, air ducts, and so on and so on. This is all doable with TPU 92A parts. And the next one shows some parts we already did for the automotive industry. And you see here some cup holder inserts or the cup holder complete, hoses, tubes, the pedal pad for the nylon printed brake or gas pedal, some bellows, and some hoses and other parts, mostly used in the automotive industry, but others as well. At the end of the TPU session, of course, some FAQs. I go a quick over it. If I buy a new F123, is the elastomer kit included, or it's an extra? In the new one, this will be included, and you find the number some pages before. Can customers install the TPU kit by themselves? Yes, of course. The installation is quick and easy, and you get the document how to do it. Will TPU be available in other slice heights? Currently, we have that only in the 0.254 millimeter slice. Will there and other colors available? At the moment, it's only available in black. So that's, just to answer the question, at the moment it's only in black. We tried to have it in other colors, but this was not working with the same mixture of material. So at the moment we keep it on the black. The next one, we come to the jigs and fixture material, but here we make a short break and asking Edith if we already have some questions from the audience.
Thank you, Michael. So we have one question from our colleague Justin. He would like to know whether the after sealing can TPU contain oil and hydrocarbons?
That's a good question. I need to check that. Depending on the sealant, of course. There is not only one sealant. In the world we're living, we have different ones. We have epoxy ones, and we have also other sealants like the BGB or something. And depends on the sealing you use. If this is I would say good enough for oils. And here's the question: which kind of oils? In the motor world, of course, we're talking about a big number of different oils, and of course, hydrocarbons. I guess you're talking about fuel, gasoline, and so on. This absolutely depends on the sealing you use. Yeah.
Thank you very much, Michael. This was it so far.
Okay. So then we dive into the advanced materials for jigs and fixtures. What is a new material since we have it more than a year now, but it's the newest one. It's the Diran 410 MF07. This you see a nice part here. What this is a perfect example for the surface quality you can do, and for the complexity of the parts we are able to produce with the F370. What was the problem? The problem was by using a traditional production, jigs and fixtures are commonly heavy because they are made of aluminium, with some screws and handles and some rubber pads or whatever you needed. That require a time to produce the single parts and assembly them, mostly with screws. They are not durable sometimes, and break when dropped because they are heavier. They have a limited functionality because you're using, whenever it was possible, standard parts and assemble them together. With that, they are expensive and require days or weeks to customize them. And of course, the freedom of design is limited. And if you are not carefully enough, you can damage your surfaces you want to you work with. So you have painted or finished or high finished polished surfaces you want to go with these tools, like with the one you see on the right side. You have scratches and marks. What needs another repairing process or a new one. The solution here for is DIRAN 410 MFO7. DIRAN is a nylon-based material and filled with minerals. So nylon-based, this is a nylon 66, yeah, to have the chemical specification. And this is filled with 7% of minerals. And this mixture is specifically formulated for use on the F370 for the production of jigs, fixtures, manufacturing aids, end-use parts if it works and needed, and so on. The material exhibit good mechanical properties and toughness. It's flexible but strong. But have in mind, this is not that tough than PCABS, for instance. Yeah, this is a different world because here we talk about nylon 66, but due to the mineral filling, this changing also the properties. But it has a high lubricity properties. What is a low surface friction, which is good for wear resistance and low scratch and mark characteristics, and it limiting damage when it contact with sensitive components. So this is perfect to keep and transport polished or painted parts, for instance. Yeah, what is the mainly attributes of the DIRAN material? It's the mechanical properties. It's tough and strong. It's perfect for lightweight design and also printing. It is a high lubricity, what limits the damage on sensitive components. It's the simple post-processing. It's a breakaway support material. This saves time in the post-processing. So the support here is like a zipper. Yeah, you peel with your thumbnail one corner of the part, and then you can remove the support like you open a zipper. And of course, it's customizable, so you can use all your innovation for the designs. It's absolutely ideal for complex, ergonomic, and lightweight, and of course for customized designs. So here the main point is the freedom of design, the ease of use, the lightweight, and the wear resistance at main attributes for the DIRAN material. Some product details. It's only compatible with the F370. It's using the standard head with tip size T14. We have 3 different slice heights. We have a 90 cubic inch spool. It's a breakaway support. You need another build tray because we're running in a higher temperature here. So this is not the same build tray as you use for ABS or ASA. The color is a darker gray, and of course it's fully compatible with GrabCAD Print and Insight software. Primary use cases is processing aids, for instance. So like this locator block using an automated washing station. This is a production aid, custom bushing for robotic cell, for instance. And here you see the assembly aid used to sort sub-assembly components on the production line. And I guess you have, if you spread your ideas and invite this to our customers, there are way more ideas and parts in the field as we can show here. And also here we have some easy FAQs prepared. Does this material require a separate build tray? Yes, as I told you, the run runs at a higher temperature in the build chamber. So we need here another build tray to avoid the parts from the warping. How does the support material work? Due to a difference in the CTE between the support material and the model material, the bulk of the support structure is printed using the model material with layers of support material separating the model material used in support and the actual model. So what it means is finally you have the support structure, you can remove it by a zipper. And the most important thing you should remember, there's a difference in the CTE. So please remove the support right after printing to avoid that the model material and the support material working against each other. Does the run or the support material require a special head? No, the run and the support 4000B support material do not require a dedicated head, so you can use the same head as you use for ASA, PCABS, or ABS. So next one, we coming to the ABS EST7, but before, I guess we do another small break. Edith, do we have some questions to the run?
Yes, Micah, one question. TPU have two slice height 0.1778 millimeter and 0.2540 millimeter. So I think this is only an adjustment or an update or feedback.
Yeah, this is an update, right? It was provided some weeks ago. I need to change the presentation. Absolutely right. I remember. Yeah,
Great.
we have a new slide height here available. True. Thanks.
That's it for now.
Okay. Thank you very much. And we go ahead with the ABS EST7 on the F370. The problem is we have in the industry a lot of electrostatic discharge, and this can degrade or destroy electrical circuits, components, or result in a fire or explosion. We can have equipment malfunctions due to a hazardous static shock, and we have some production parts through traditional methods, metal and plated materials. They can be heavy and costly. So we need here a solution, and this is the ABS EST7. This is a material filled with carbon nanotubes. They are compounded or blended into the ABS plastic, making it static dissipative and prevents buildup of static electricity. It will not produce a static shock or cause other materials like powders, dust, and fine particles to stick to it. Our current ABS EST7 material is now available on the F370. So this is the same material you know from the Effectors series. Provides a lower entry cost to customers looking to produce ESD safe jigs and fixtures and assembly and end-use parts. What is the main attributes of the ESD7 on this F370? Yeah, the first and most important, we have an ESD performance for housings to protect sensitive instruments. We have a lower cost than for the Effectors machines. We have soluble automatic post-processing. So we run here also with the typical soluble support, QSR, to create parts and fine details with an easy support removal. Of course, the parts are customizable, so we don't need to use standard parts and assemble them or give them a special finish. Here we can print the design we need. We can be very innovative, and the design can follow the function, all the aesthetics and the simplicity of the parts. So the main points here is safety and protection. It's the cost effectiveness, the freedom of design, and the ease of use. Some product details for the ABS EST7 is a successful usage on the Fortus 380, 450, and 900. And it's now also compatible with the F370. The head size is the standard T14 with the 10 slice layer thickness. Spool size, as usual, 90 cubic inch. Runs with the QSR in the 60 cubic inch spool. And of course, the software is available, grab can print, and inside, and the color is black, what is given to the nanotubes we use in this material. And the effect the material will dissipate as a kind of a bleed off static charge. So and the volume resistivity is between 10 upper 3 and 10 upper 9 ohms for the surface here. Primary use cases is to protect electronic from EST damage, is preventing a fire explosion by sparks, and preventing equipment and product performance for aesthetic cling. So this is the main applications for this material. And also here, very short, we have some FAQs. What does ESD mean? In between, I guess everybody knows, it stands for electrostatic dissipative. What is triboelectric charging? As triboelectric charging is the term used for the build-up of an electric charge caused by rubbing two materials together. We knows that if we have a pullover from and we rub our hands on that, we build up an electric charging, and this is not the case with an ESD safe material. And what is the surface resistance? This is a measure of how easy an electrical charge can flow across a single surface, and not through a part. So we have an electrical flow over the surface and not through the part. Surface resistance is measured in ohms, and it is the ratio of DC voltage to the current that flows across the surface. And of course, this surface resistance is dependent on the smoothness of the surface, on the structure of the surface, and so on. This all affects that. How is surface resistance measured? A surface resistivity or resistance meter measures the value. Electrodes are placed on the surface, same side, of the tested sample. The meter reports the DC voltage to current ratio between the two electrodes. So this is a quite easy procedure. Can you tell us more about the static dissipative? Static dissipative materials fall between insulators and conductors. So this is the world between, I would say, metals and plastics. Or wood is also a perfect insulator. Most plastics are great electrical insulators. They don't transmit electricity very well. Metal, on the other hand, is a great conductor, and electricity freely flows through it. Static dissipative materials act a little like both. You wouldn't use them when you want an electrical conductor or electrical insulator, but you do want to use them when you when the material needs to shed, bleed, drain, or dissipate an electrical charge. Yeah, by the numbers here you see how is the ranking. An insulator is above 10 upper 9 ohms, a conductor is below 10 upper 3 ohms, and static dissipative materials acting in between the both, of course, depending on the surface you build up and so on. Is surface resistance the same as surface resistivity? No, surface resistivity is a calculation of the resistance of an area, not point-to-point measurement used for surface resistance. An important difference is that surface resistivity measured in ohms per square and square ohms will be 10 times a factor 10 higher than surface resistance, which is measured in ohms. Surface resistivity is used to evaluate insulative materials where high resistance is desirable. Surface resistance is used to evaluate static dissipative material when lower resistance is needed. So what is the ABS EC7 surface resistance? ABS EC7 will range between, we already talked about it, 10 upper 3 ohms and 10 upper 9 ohms, with most geometries measuring between 10 upper 5 and 10 upper 6 ohms. And here we're using the same standard F370 head as the last question. And before we come to the new case study we have in this presentation, again, Edith, do we have some questions?
So we have a question and some feedback from Turkey coming in. Thank you, Utku. Why there is only one slice height for ESD7? We sometimes print very large parts filling all the F900 plate, but the print time really kills.
Yeah, that's a good question. I guess this is for the moment a compromise to print this material on the single head and not having a different tip sizes because of the filling. But at the moment, I don't know if we plan to have different slice heights here as well. This is the only answer I have in the moment. So please do me a favor, drop me a mail, and I will ask in the headquarter why we have only the one slice height, and if we plan to add more slices, also different slice heights here, especially for bigger parts. Maybe yeah, and higher slice. Yeah,
Sounds
please,
good, Michael. Thank you.
yeah, drop me a mail, please, Utku. That makes it easier.
So that was it for the moment again.
Okay, thank you, Edith. Then we coming to the most important thing of this presentation, to talk about the new case studies. Sorry. At first, starting with something easy, from the Milwaukee School of Engineering. They used in the education sector, they used the TPU 92A. The challenge here is this Milwaukee School of Engineering, MSOI, does more than simple house an additive lab. The RP Center employs students who work with an industry to help the business solve unique challenges focused on the new product development. So finally, they need some flexible parts. Solution here with the interchangeable print head and an easy and fast changing from other materials to TPU. It's quite easy and fast to print and produce TPU parts for the industry and for the development of new parts. And the impact, the partnership between the education industry, preparing career-ready students, also via the Stratasys certification program. It means the companies can hire future employees with a confidence they need to ensure that an employee has a comprehensive knowledge of additive manufacturing and knows about um, the, um, the possibilities are given by a flexible system, by different materials, and so on. So they are already trained and having at least a basic knowledge about the 3D printing applications and systems. Another one is for form automation and an end of arm tool. It comes from Laserlines from the UK. We have an automatic insertion of absorbent pads into food trays. Also here we use the TPU 92A. The challenge is improve existing process for the end of arm tools. We have some gripper fingers, what you see here on the picture, can bend out of shape. Small loose parts can possibly fall into food trays, what is not good if you if you buy the food later and you find some robot fingers in or some parts inside. This is not a good moment. And of course, they are manufactured externally and not in-house. So the solution here is an additively manufactured two-component solution. This is a TPU spring placed into an ASA frame. What you can see here, this is the old version, this is the new version, and it drives us to the benefits. The assembly reduced from 20 to 2 pieces, and it's very easy to assemble. The flexible materials is less likely to break. It's easy to replace if necessary, resulting in reduced maintenance efforts. The weight is reduced by 50%. It's faster and more efficient to run, and overall you have a 35% of cost saving with this new application. The third one is something, it looks easy, yeah, but if you need it and it helps you a lot, as the most of the easy things, it's just easy in manufacturing tool example. When you need a soft touch with a TPU 92A. The challenge here was a need to protect final products against scratches if required a self-sufficient and fast solution. The solution here comes from the Stratasys TPU 92A. It's produced in-house on the F123 printer, and the benefits in less than 1 hour from a simple card to print to deployment. The costs are very, very low with less than 10 US dollars as an alternative. And the self-sufficiency from concept to deployment. Yeah, if you have such an idea, you make an easy drawing, you go to the machine, you print these cover parts, slip it over your tools, and you have a perfect solution in a very short time, and yeah, save and protect your parts from scratching. This is like it works. Yeah, you have this is the same in English, so we can jump over that. And coming to the next one with Polaris, the company Polaris. Maybe you know the motorcycle brand Indian. The challenge here is the introduction of a 3D printed FDM elastomer material has been a real advantage For Polaris, the materials flexibility provides the right answer to a number of different applications, speeding the production and validation of flexible part designs. Using a customer allows us to contact the painted surface right out of the paint shop without any damagings, giving us a real quick lead time. And this is the words of Dan Wiatowski. Elastomer materials have also saved the production time on other vital components, such as the VIN label guard, and 3D printed elastomer also accelerates the design of flexible parts. It let designers quickly refine the design of a flexible vehicle cup holder, for instance. And this brings us to some benefits. The use of elastomer materials has enabled the team of Polaris to rapidly iterate and test multiple geometrically accurate designs for the intake duct of one of their vehicles. And this, you see here some pictures of hoses, of covers for placing on fresh painted components of the motorcycle. That shows us with the next picture. And here I want to show you the Polaris movie. Sorry you don't hear the sound, but if you download the application, the presentation, you have the full video with the sound.
Regular hard plastic 3D printing materials up to some of the more
innovative. You see here the covers printed.
Being able to come up with a design, test it, improve on it, and repeat until we get to a good final product. We install a lot of complex parts, badging, headdresses, things of that nature to our bikes. Having the ability to 3D print that complex geometry quickly and in a variety of materials gives us a lot of flexibility. We work with a lot of foam and painted parts, and we have strict cosmetic standards that we need to hold for our customers. So this is where the elastomer materials fit so well into our needs. They're soft enough to not damage our cosmetic parts, but durable enough to withstand our assembly manufacturing environment. So one of the more recent projects we worked on was our rear fender strip working. These production quality guards have taken the place of a lot of leather and vacuum form parts, which are very time consuming to produce. So here at Polaris, we do incur prototype cleaning costs. So what Stratasys technology allows us to not only cut those costs significantly, but also cut our time for tooling. This actually will allow us to stretch it into other areas that we would not produce with traditional 3D printing technology.
This has been a huge benefit to the team. Instead of waiting anywhere between 8 to 12 weeks, we're able to get designs within 24 hours. So you have more iterations on the design process up front, so that you have greater confidence when you go to kick off your final tools for production. One example that we had was when designing a new interior cup holder for a vehicle has allowed us to see overall integration into the interior faster. Actually having to parts and having things out goes a long way. Sometimes we can a lot of real benefits. So being able to see the part in real life and test different scenarios and make sure that it fit into the new interior was a huge benefit for us.
We've been working with Stratasys for over 20 years, and our partnership with Stratasys allows us to have robust printing capabilities in-house, reduces their lead time and lowers their cost. Working with Stratasys has helped us open our minds on what's possible with very complex problems and geometries, come up with good solutions to enable productivity, quality, and speed of our manufacturing process. The quality of Stratasys equipment gives us the confidence that we're going to get a good part the first time, every time. The early exposure to new materials has been very helpful. So being on the front line of the new elastomer material and getting to try that and use it in production early has been super helpful. It's really broadened our horizons on what we can do with 3D printing, applications we would not have previously considered. Polaris is really excited about the future of additive manufacturing, and we're looking forward to continuing the partnership with Stratasys.
So this was the Polaris movie. And the next one is showing us a robot gripper, here with soft touch fingers in the combination with a harder material. So we have a TPU finger, we have an ASA fixture, the locker, and the air intake here on the top. The application here is a customized tool on an end of arm robotic end of arm. It requires a soft touch or articulation, frequently required with automation and manufacturing equipment. And the benefits here, it's easily to customize to product or the equipment. It reduces the outsourcing time and the costs, and you can produce it on demand with using it as a digital inventory, so you don't need to order 500 of these grippers and put it in the shelf in your stock, and so it saves the place there, and you can produce it, and you have some easy changes or general changes on the geometry. You can immediately change the design and print new ones. So the next one shows us here a small movie. You see it from this gripper. How does it work? Now you see the perfect combination of the ASA frame and the TPU grippers. And you see here a picture how this is designed from the inside. Yeah, works with an air compressor, and you have different structures. And if you bring air in, the bending goes in one direction and closing the fingers together and hold the cup or whatever you need to hold and transport. The next one of the use cases is it's quite a large, complex, and the gold medal worthy use case. It's a company based in Minnesota. Project was created by Mike Schultz, an athlete that lost his leg on a snowmobile accident, and using TPU for prosthetics. The TPU was used as a durable material that could provide damping and protection and sit in between a silicon pad protected by a custom-made carbon fiber cover that sits on the amputee and the bionic leg. The special leg is used for extreme sports. You see here on the bike, and here you see this carbon fiber parts and the TPU sleeve in between. Here, the next one is an N-vent. It's from N-vent, the manifold for test fixtures. This is done with Diran, the nylon 6.6 filled with minerals. The challenge here is to make a leak test, a large water distribution manifold into a new test chamber. The tool needs to be durable enough to accommodate up to 40 load-unload cycles per day. And the solution, the engineers printed a single piece support on the Stratasys F370 using the new Diran material. The run was printed in 22 hours, and this is much shorter than the 2 to 3 weeks was the lead time if you need to machine such components and you need to wait for. The most important things here, lead time savings is up to 90%, and the material cost savings is 56%. So what is nearly half the price. Coming to another case for ESD7, you see here some nice pictures in the production. This together, ESD7, nylon 12CF, and Antero are anti-static materials. So yeah, also the Antero 840 CNO3 is an PEG ESD material, and the nylon 12 CF shows some anti-static material properties due to the carbon filling in this material. RICO replaces metal jigs with thermoplastic parts with ESD properties. This can be customized and give us a lightweight jigs and fixtures in only 1 day versus 2 days on other traditional manufacturings. And the operator efficiency and satisfaction is improved significantly. So this is make just the life for the worker easier. So what's next? Just want to introduce a new GrabCAD feature. It's the adaptive slice height. It decreases the print time with an adaptive slice height in GrabCAD, starting with version 1.45. The adaptive slice height is a new software feature that will automatically vary the slice height within a part to decrease printing time while retaining the part quality and strength. Here you see an example between the 7 slice and the 10 slice. Just some highlights. We can increase the speed, the print speed, up to 24%. Of course, this depends on the part geometry. There is no change in part strength. This is available on F900, 900C, 450, 370, and 270. This is available on all FDM materials, and we have 2 versions here. This is for for 1.178 millimeters and 0 to 54 millimeter slices, and this is already available since August 25th. Just for the case you never worked with that or you didn't get the information. And here this is an automatic process. Here you switch it on and the system automatically detects the features we can reduce or increase the slice to getting faster. In summary, the F370 solves your pains related to 3D printing for the complete RP cycle and jigs and fixtures. Again, we use them for concept and design validation, functional performance parts, and mainly, a lot of for jigs and fixtures as well. And with that, I'm come to the end. Say many thanks, and now we can have some minutes for your questions.
Thank you very much, Michael. So we have some questions here from our reseller in Turkey again. Thank you, Ali. First, due to the capability of printing all slice heights with a tip set, why is the adaptive slice height option not available for other F123 systems?
No, it's available for the F270 and F370.
Okay.
I mean, finally, we need a differentiator in the selling cycle. Yeah, this is a decision. It's in my mind, this is not a technical issue. This is I would say sales related issue to have a differentiator to have more unique selling points on the 370 and 270 related or compared to the simple F120 or F170.
Okay. And Utku is asking also about the adaptive slice height. Does it work in both options, increasing and decreasing slice height?
No, at the moment, also this is one point. Yeah, I don't know if you think about this in the future, but it works only in the one direction. Yeah, you load a part on the platform. You see, okay, you have some fine features on the part, and your choice is a lower slice height. And then you set the checkbox to adaptive slice, and then the system decides where to increase the slice height where you have an easy geometry, and this saves printing time without changing mechanical properties. So at the moment it runs only in this one direction. Yeah, I don't know what coming next year or in 2 years. Yeah, I really don't know. Maybe we have a complete different solution or widen this one, but for the moment it runs um, in two versions. Yeah, it increases the slice height one step to speed up the print for this part.
Thank you, Michael. So this is, looks really good discussion here with specialists. I have another one. When I choose T16, is it increasing also to T20?
T20 is 0.5 millimeter. This is not working. No. This is not working at the moment. We have only these two jumps. If you like, we have a very dedicated new presentation I got this morning from GrabCAD. Explains in which slice height it works, but it's not stepping up to T20. No.
Okay, so that's it for now. Thank you very much, Michael. There is also one more thanks from Justin. Great presentation, good feedbacks, and no further questions.
Okay, then as I want to say many thanks, Edith, for hosting us today, and many thanks to all the attendees spending your time with us. Please use this presentation, download the presentation from our website, from my Stratasys, from the academy. Use the recording, and distribute. You can tailor whatever you want. If you need more, please contact us directly with an email or a call. And I want to say, okay, enjoy your lunch next time, wherever you are in this world. Keep and stay safe, and many thanks.
Thank you everybody, and have a good afternoon. Goodbye.
Thank you. Bye bye.